Hello, my name is Anya Sinha, and today I will be presenting my research on investigating sex differences in chronic pain. For a brief introduction, I am a rising senior at Maryville High School, located in Ottawa, Canada, and enrolled in the International Baccalaureate program. At school, I am the president of the Interact Rotary Club, and I co-lead the Best Buddies program for students with autism spectrum disorders. I volunteer as a mental health advocate with the Children's Hospital of Eastern Ontario and the Youth Services Bureau. Last summer, I interned with the Hildebrand Lab in the Department of Neuroscience at Carleton University, and I am continuing to contribute to chronic pain research within this lab currently. These experiences fuel my interest in understanding and ultimately addressing disparities in global health issues. One such global health issue is chronic pain. We've all experienced pain before. The International Association for the Study of Pain defines it as an unpleasant sensory and emotional experience tied to actual or potential tissue damage. Acute pain is beneficial. It's a short-term defense, like reflexively withdrawing your hand from something hot and protecting you from further harm. However, chronic pain is not beneficial. In 2018, the World Health Organization classified it as a disease, not just a symptom. Chronic pain is any pain lasting over 3 months. While my research interest is biological, the disease is often viewed through the biopsychosocial model and is influenced by factors like relationships and mood. Beyond the pain itself, it is linked to sleep and mood disorders, metabolic changes, and an elevated risk of suicide, making it difficult to maintain work, relationships, and daily activities. Ultimately, chronic pain degrades the quality of life for 1.5 billion people worldwide. This burden isn't evenly distributed, as high rates of chronic pain correlate with low socioeconomic status, and it's more prevalent in elderly populations, which is important as many countries have aging populations. My core interest lies in the disproportionate impact of chronic pain on women. Half of all chronic pain conditions are more common in women, while only a fifth are more common in men. Women also receive less treatment and experience more severe, persistent, and recurring pain. A significant challenge in addressing this disparity stems from traditional approaches to pain research. Many past studies primarily focused on male subjects, meaning we often try to understand women's pain using insights primarily drawn from men. To illustrate, imagine trying to repair one phone with another model's manual. Though seemingly similar, their internal wiring, software, and components can differ in critical ways. This is particularly relevant because biological females have key differences in their internal cellular and molecular biology, so findings from male-centric studies can't necessarily be directly translated to females when developing chronic pain treatments. To truly understand these different wirings and how pain signals are processed, we first need to grasp the fundamental pain pathway. Imagine you've touched a burning pan. When tissue is damaged, specialized sensors called nociceptors detect the painful stimulus. These sensors are found on the ends of special nerve cells called sensory neurons, which are like wires that carry information. They send the signal from your finger up towards your spinal cord, where it is then passed on to other nerve cells. These cells then carry the signal all the way up through the spinal cord to your brain, where it is finally interpreted as pain. However, what happens when this intricate pain pathway goes wrong? In chronic neuropathic pain, which is caused by damage or disease to the nervous system itself, like from a nerve injury, this pathway is disrupted. This type of chronic pain is also more common in females. This brings us back to that idea of different internal wiring, software, and components between both sexes. Given how prevalent and debilitating chronic neuropathic pain is, especially in women, I was fascinated to explore a critical question through a literature review. How do the specific molecular pathways underlying neuropathic pain differ between males and females? In this presentation, I will share some of the main findings. Understanding these mechanisms in both biological sexes is absolutely crucial for developing effective treatments for everyone. So, let's look deeper into the mechanisms of pain. As we discussed, peripheral nerve injury can lead to neuropathic pain. When a nerve is damaged, a series of complex events happens at the cellular and molecular level. This injury mainly causes two key events in the spinal cord. One is an increase in microglia. Two is an increase in the number of P2X4 receptors, or P2X4Rs. These are specific receptor proteins found on those microglia, and when they become more numerous, they contribute to making you more sensitive to pain. Microglia are truly fascinating. While they are the brain and spinal cord's main immune cells, recent studies on chronic neuropathic pain have increasingly shown they play a crucial role in the condition itself, going beyond just fighting infection. That simplified diagram, however, doesn't tell the whole story. What we've learned from more modern studies, which included both male and female subjects, are some truly intriguing and important differences. For instance, that P2X4 receptor pathway, which causes microglia to respond to nerve injury and amp up pains in males, is not necessarily activated in females. While both sexes have molecules that control microglial genes, in females, a specific molecule called IRF5 doesn't activate the P2X4 receptor gene in the same way it does for males. This helps explain why the P2X4 receptor pathway isn't engaged in females. However, this doesn't mean that microglia are irrelevant in female pain. In fact, their role in females seems to involve more complex molecular interactions. For example, if female mice are given testosterone, the primary male sex hormone, it can activate the P2X4 receptor pathway. Furthermore, microglia are found to contribute to pain during early pregnancy and in certain conditions like bone cancer pain in females. Studies also show that in females lacking other key immune cells, like T and B cells, microglia still play an important role in pain, highlighting these intricate immune interactions. So, where does this leave us? We started by recognizing the significant burden of chronic pain globally, affecting over 1 billion people worldwide. Within this immense challenge, we then delved into a critical and often overlooked disparity, the disproportionate impact of chronic pain on women, who often receive less treatment. My literature review aimed to shed light on why this may be the case by exploring the fundamental molecular pathways of neuropathic pain in both sexes. While a basic pain pathway exists, modern research reveals striking differences in the internal wiring and software of pain mechanisms between males and females. Ultimately, to develop a more accurate and complete instruction manual for pain in both biological sexes, we need to continue towards more inclusivity in research, such as policies mandating the use of male and female subjects. As the next generation of global health advocates, we must continue to shed light on disparities in global health to move towards an equitable world. These are my references, and I'd like to thank the Global Health Leaders Conference for providing this opportunity to share my work and passion, as well as the Hildebrand Lab at Carleton University for supporting my research interests. I would also like to thank my family and teachers for supporting me. Thank you all for listening, and feel free to connect.